Hi guys, welcome to your Unit 4 Lesson 3 notes on graphing linear relations. Now when you look at this linear right here, think line, because there's a line in linear and that's where we draw the line. Ha ha ha. Okay, well anyway. So by the end of the day, you'll be able to graph linear relations. So here we go. Here we've got this graph of the line and we've got a table over here. So let's look at it. What can you tell? The graph of the line includes, what do you think? All possible solutions, infinite of the equation, linear equation, ordered pair. The graph of this line includes all possible solutions of the line, of the equation. So we see right here that there are 5 points that all fit on this line. These 5 points, these 5 pairs are all solutions of this equation, where each of these x values, when you plug them in for x, you get each of these y values out. And that's where each of these points come in. But guess what? There are also points in between these points. There's some points right here and right here. There are some points between these points, right here, right here, right here. There's literally an infinite number of points on this graph. And if you understand that, then you've got the key idea of the whole day. Isn't that great? Oh, hey. So you can say that this line contains an infinite number of points. And it looks like 5, but there's actually a million little points all throughout here. In fact, there's way more than a million. There's infinity. So every point has its own ordered pair. So that every ordered pair for every point on the line is a solution of the equation. So no matter what you pick here, each of these x's and y's will make this statement true. If we look at -2, 0, for example, -2 plus 2 is in fact 0. So if we had plugged this in where x is -2 and y is 0, is it true that 0 equals -2 plus 2? Yeah, that's true. It's a solution. Each of these is a solution to this line. Isn't that great? So an equation whose graph is a straight line, we call that, oh, sorry, I just crossed it out, wrong thing. We call that a linear equation. The reason it's called a linear equation is because you have a equation that's a line. We could say, oh, that's a liney equation, but that's not how English works. We say it's linear, just like circular, rectangular. We have linear, because it's a line. Linear. Yay! Okay, sweet. Well, what does this mean? This isn't standard form. There's a standard way to write lines, and standard form looks like this. So a linear equation is an equation in the form of a times x plus b times y equals c. Remember, whenever we have x, y in this class, we make our x's yellow and we make our y's green, just so they're easier to graph. Where a, b, and c can be any numbers, but a and b aren't 0. So you have ax plus by equals c. And when they're written like this, we call that standard form. We have to make sure that a is not 0, by the way. So there you go. Isn't that so fun? So fun. So now we need to determine, are these guys in standard form or not? Well, this one's not quite in standard form because we need to put our x and our y on the same side. So to do that, we're going to do minus y, and that gives us 3x minus y equals 5. And here we have that in standard form, because that could be the same thing as 3x plus negative y equals 5, and there you have it, whatever. But good enough, good enough, good enough. Hey, is it linear, by the way? It is, because all linear equations have an x and a y and no exponents. I should have made that like an official thing. This is very important, you guys. In order to be a linear equation, you need to have an x and a y, and you can't have any exponents on them. So, let's look at B. Is this a linear equation? Well, we've got an x, we've got a y, but here we have x and y times each other. That's not okay. We need to have x and y added to each other, because my notability froze. Okay, good. We need to have x and y like added. They can't be multiplied. So no, this is not linear. And then finally, is this linear? Well, it actually depends on who you ask. So according to like the textbook, this isn't linear, but I argue that it is because it makes a straight line. Also, this is the same thing as saying x plus 0y equals -2. So yeah, I say that that is a line. That's a linear equation. Okay, great. So we said that a linear equation is a graph that makes a line. So how do we know? How do we actually graph a linear equation? Well, the first step is to create a table of ordered pairs. That will give you your points. And then we graph those points. As the ordered pairs give us your coordinates. And then finally, we'll connect those points with a line. So here we go. We've got some x values. We need to find out what our y values are. What our y values are. English. And then we'll put them on our graph. We've got x-axis, we've got our y-axis. And we'll plot them accordingly. Coordinately is a joke. Okay, so how do we know what to put here? Well, in order to find out what y is, we solve for y. Fortunately, this already has y by itself. And then we take this 2x minus 3, and we plug our x's all in for there. So we'll have 2 times whatever our x value is, minus 3, and then figure out what is that. Okay. Well, we're gonna do this process across all of them. Here we go. So for our first one, let's plug in -2 for x. 2 times -2 is -4, which minus 3 is -7. And then 2 times -1 is -2, which minus 3 is -5. After that, we have 2 times 0. I love 2 times 0. It's just 0. And minus 3, you get -3. And then from 1, we have 2 times 1 is 2, minus 3 is -1. And finally for 2 times 2 is 4, minus 3 gives us a positive 1. Excellent. Now you'll notice a pattern. I won't talk about it. I promise I won't. Okay, here we go. So let's put those into x, y points. That gives us -2, -7, -1, -5, 0, -3, 1, -1, and 2, 1. So we're going to use all of our x's, tell us right or left, and all of our y's, tell us up or down. So to graph -2, -7, we go backwards 2, wrong thing. We go backwards 2, down 7. Oh, it's also important to label your axes. I just like to label every other one because it's easier. So this is -2, -4, and then -2, -4, -6, which gives us -7 right there. Oh man, I lost my highlighting. I found my highlighting. Okay. Then -1, -5. We go back 1, down 5. -1, 5 is right. -1, -5, that is right there. 0, down 3, over 1, down 1, over 2, up 1. And if we did this right, you guys, then all connect in a straight line. I didn't draw my line correctly. They'll all connect in a straight line. Oh, hey, look, they all lie on my line. And what's great about Notability is it does straight lines for you. So there you have it. We graphed our line. That's fun, right? Now, there are two ways to graph standard form. The first technical way is to graph their intercepts, which means find out what x is when y is 0. I'll show you this way real fast and then show you how to solve it for y. So I like the 0 way better because it's faster. So that says you take 2x plus 4y equals 8, and then you say, well, what if x equals 0? And then what if y equals 0? If x equals 0, then you have 2 times 0 plus 4y equals 8, and 2 times 0 is just 0. So 4y equals 8, so y equals 2. So that gives you the point over 0, up 2. And that's what you call your y-intercept. So when we put them on a graph here, we've got our y-axis, we've got our x-axis. You say, okay, 0, 2, we go over 0, up 2, boom, there we are. And then after setting x equal to 0 to find our y-intercept, we find our x-intercept by setting y equal to 0. And we say, well, what happens if y equals 0? You have 2x plus 4y equals 8, but y is 0, so 2x plus 4 times 0 equals 8. Guess I didn't need to rewrite this. Okay. Well, that's 2x equals 8, dividing both sides by 2 gives you x equals 4. So when y is 0, x is 4. So you go, that gives us the point 4 is 0. You go over 1, 2, 3, 4. 1, 2, 3, 4. And there you have it. There's your line. You just connect these guys. Come on. You just connect these guys. Why won't it snap? It's not snapping, guys. Ah, there it goes. You just connect these guys, like I said, and that gives you your graph. However, that way can be kind of tricky to remember what to do. So if you would rather, you can solve for y. So in solving for y, you have 2x plus 4y equals 8. You minus 2x from both sides, giving you 4y equals 8 minus 2x. And then you divide by 4 to get y all by itself. Hey, look, we have 8 minus 2x all over 4. And then we need to plug in x for all of our values right here. Okay, so on our first one, that'll give us 8 minus 2 times negative 2 all over 4. And I need to do a bit of work to find out what that is. 2 times negative 2 is negative 4. When you have two negatives, you have negative 2 times negative 4 is 4. So you have 8 plus 4 all over 4, which is 12 divided by 4, which is 3. So we plugged in negative 2 in for x, and we got 3. And in the interest of time, following that same process, we get 2.5, 2, 1.5, and 1. So we've got our x's, we've got our y's, which gives us our points, negative 2, 3, negative 1, 2.5, 0, 2, 1, 1.5, and 2, 1. Now let's put those on our graph. We go back 2, up 3. Oh, hey. And then we go back 1, up 2.5. Oh, hey. And we go over 0, up 2, but we knew that already. We go over 1, up 1.5, then over 2, up 1. But notice how all these dots already lie on the line that we already graphed. So good. That's how you know you did it right. Okay, cool. Great. Okay, we have two special cases and then a word problem, and we'll call it a day. Here, check it out. What happens if y equals 2? Well, to show you, let's do a very basic table, x, y, and let's pick some x's and y's. So if we have like -2, 0, 1, and 3, if x is -2, if x is -2, y is 2. That's the rule. Y is 2. If x is 0, y is 2. If x is 1, y is 2. Okay, it's always 2 because that was the rule. Yay! So let's plot our points. Over 2, up 2. Over 0, up 2. Over 1, up 2. Over 3, up 2. Yay! Whenever you have y equals anything, it will look like this. It's a horizontal line. That's always the case. If you have y equals some number, that's going to be a horizontal line. If you have x on the other hand, and we say that has no slope, or we say slope equals 0, but we'll get to that later. And then for our next one, where you have undefined slope, that's when you have x equals something. X equals -3 in this case. So if we plug this into our table, that means when x is -3, y is, it doesn't matter. We can in fact do this backwards. We could say, let's plug in some points here. Okay, sure. But x is always going to be -3 because that's the rule. X is -3. So we have some points. We go 1, 2, 3, back 3, up 5. 1, 2, 3, 4, hey, 5. Over -3, up 4. Over -3, down -3. Over -3, up 0. This line is always here. Okay. So if you ever have x equals something, that's going to be a vertical line. And we say the slope is undefined. Some people will tell you it's infinity, but it's undefined. Okay, last one. So Old Faithful is a geyser in Yellowstone National Park, and it's famous for its predictable eruptions. You can always tell when it's going to go off next. So this equation right here, y equals 14x plus 27, can be used to predict its eruptions, where y is the time until the next eruption in minutes, and x is the length of the eruption in minutes. So suppose Old Faithful erupts at 9:46 for 3.4 minutes. About what time will the next eruption occur? Well, first let's graph the equation. So remember that x is the length of the eruption. So however long it took the geyser to erupt, that's our x. So if the eruption lasted for a minute, the next eruption will come a lot sooner. And then our y is going to be time until the next eruption. So let's highlight that into 2. Y is the time until the next eruption. Now that we know what our variables represent, let's label our axes real quick. X is the length of the eruption, so let's put that here on our x-axis. Length of eruption in minutes. And now what was y? So that's the x is the length of the eruption. And then we have y. What was y though? Y is the time until the next eruption. So let's put that over here. Time until the next eruption. Ta-da! Oh, in minutes. I'm so sorry. Boom. Okay, sweetums. So now let's graph our line. We've got to find out where to put it. So we have 14 times x plus 27 will give us 14 times something plus 27. Okay. Ta-da! Okay, we have 14 times 1 plus 27, which is 14 plus 27, giving us 41. And then 14 times 2 plus 27, which is 28 plus 27, giving us 55. 14 times 3 plus 27 is 69. 14 times 4 plus 27 is 83. And finally, 14 times 5 is 70 plus 27 gives us 97. So there we have our points. We have 1, 41, 2, 55, 3, 69, 4, 83, and 5, 97. So let's plot those points on our graph. I notice we only go up to 5, and I have 10 slots here, so I'm going to spread them out. Because you don't always have to go 1, 2, 3, 4, 5, done. So let's go 1, 2, 3, 4, 5, like that. And then our y's go up to 97. But this only goes up to 8. I think I just cropped it weird. So we have 1, so 10, 20, 30, 40, 50, 60, 70, 80. Watch this, you guys. This is a notability skill. We're gonna continue this up. Ha 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 ha. Isn't that great? That's so fun. Yay! Improvise, adapt, overcome. Okay, anyway, so here we've got our points. On our table, we had 1, 41. We go over 1, up 41. Oh, tiny, like right there. Okay, nice. And then over 2, up 55. Like here. Over 3, up 69, right under 70. Over 4, up 83. And then over 5, up 97. Oh shoot, we didn't go nearly high enough. Oh well, whatever. We're not gonna deal with it, because guess what? If it erupted for 3.4 minutes, that's what we're gonna care about on our graph. So we find the length of eruption being 3.4 minutes, which is right underneath 3.5. So go up right here. Boom. That vertical. Oh, you guys, we didn't actually connect our line. Yipes. Okay, so we find a line that runs through all of our points. That's not going to do it, though. So how can we connect these? How about there? Good enough. Okay, now we need to figure out, hey, what y value is this at? If we have them intersecting, where's my horizontal line? There's my horizontal line. Like right there, we need to figure out where is that. So what I'm looking at, guys, is we need to find what is the coordinates of this point. We already know we go over 3.4, but how high is that? How high is that point? Oh, good enough. So let's follow it over here. And what would you say that is? About 75? Let's go with 75. There you go. So we did it. If an eruption lasts 3.4 minutes, the next eruption will occur in about 75 minutes. Yay! But when is it? Because it said about what time will the next eruption occur. That was at 9:46. We need to take 9:46 and then add 75 minutes. So 75 minutes after 9:46. How are we going to figure that out? Well, let's use the distributive property. 75, I think you'll agree, is 60 plus 15, right? And 60 minutes is 1 hour. So let's add an hour first, and then let's add 15 minutes. Okay, so an hour would give us 10:46, but then we still need to add 15 minutes. Oh, 14 minutes will get us to 11. So it's going to be 11:01. So our next interruption will occur at 11:01. Yay! That's it. So graphs. Basically, to make a graph, you get your equation, you plug in your x's to find out what your y's are, and then you find, hey, when is y going to equal what I want it to? Or what happens when x equals what I want it to? That's it. Have a fantastic time on your homework.